Maths exams are just around the corner. Join me in these revision sessions to either salvage your exams or absolutely destroy them by learning something new. God damn, looking at this gives me a pit in my stomach. This is what I would deem as a very hard problem because it tests trig skills for the nth degree. Well, except the first part. For the differential, as long as you remember the quotient rule, you are chilling. Take the function on top, 1. Take the one on the bottom, sine, and differentiate them. Chain them together and then apply the quotient formula. You will be left with minus cos over sine squared theta. This of course can be broken down into cot and cosec as requested. Next, show that cos theta is equal to all of that. I'll be fully honest, I overcomplicated this. I did it by saying that sine theta is equal to 1 y, using sine squared theta plus cos squared theta is equal to 1, and then placing it all into the formulas, and as I show here. This was unnecessary as I could have just substituted cosec theta inside the given formula and then showed that it makes cos theta. Sometimes I really am my worst enemy. But you learned a new thing today. Finally, the big rate boss. Solve for the integral. This one is tough. You gotta sub in your x as 2 cosec u everywhere. And then observe that the inside of the square root can be turned into 1 plus cot squared u. This leads to having just 4 cot squared u inside the bracket, which reduces to 2 cot u. You then gotta rearrange for dx and turn it into minus 2 cot u cosec du, as from the previous part, where you had to just differentiate cosec u and sub it into the original formula. The cot cancels out with the one on the bottom, the cosec cancels out with the one on the bottom again, leaving you with just minus 1 over 4 cosec u, which is of course sine u. Taking the minus 1 over 4 outside the integral leaves you with the final answer. The question is grim, worthy of a final exam.